Hello, good morning everybody. I am going to present a small lecture on the module 5 of your engineering chemistry. That is nothing but the stereochemistry. So, in order to know about stereochemistry, we first have to know what is organic chemistry. So, organic chemistry is the branch of chemistry that contains carbon as the main element. Other elements are the hydrogen, nitrogen and oxygen. The preliminary organic compound is methane. What does it contain? It contains carbon and hydrogen. Similarly, just look at this. CH3Cl, methyl cyanide. What does it contain? It contains carbon, hydrogen and nitrogen. Similarly, proceed to the CH3CHO. What does it contain? It contains carbon, hydrogen and oxygen. Now we will have to know about the valency of the carbon. Just look at this. Carbon. Carbon means 1s2, 2s2, 2p2. So how many valence electrons are present in the carbon? 2 plus 2 means 4. We know every atom tries to complete its inner shell. So how many electrons are required to complete the inner shell? 8. So it is how many electron deficient? It is 4 electron deficient. So carbon will try to form bond with 4 atoms. Just look at this. It has formed bond with 4 hydrogen. From this we can conclude that carbon has 4 hands. Now we are proceeding to the next slide. Now we have to know an important concept, functional group. Just look at this, CH3OH, methyl alcohol. This molecule contains 2 parts. One part is the CH3, another part is the OH. What does CH3 do? It controls the physical properties of the compound. Physical properties means melting point, boiling point, solubility. And what does OH do? OH controls the chemical properties of the compound. So the part which controls the chemical properties of the compound, we called it functional group. So which one is the functional group here? The functional group here is OH or hydroxy. So again I am telling, we are proceeding to methyl alcohol. This molecule contains 2 parts. One part is the CH3, another part is the OH. CH3, what does CH3 control? CH3 controls the physical properties of the compound like melting point, boiling point, solubility. And what does OH controls? OH controls the chemical properties of the compound. The part which controls the chemical properties of the compound, they are known as functional group. So which one is the functional group here? The functional group is OH. Now we are taking this example. CH3 controls the physical properties, OH controls the chemical properties. Which one is the functional group? OH is the functional group. Next, what are the important functional groups possible? So OH, it is known as alcohol. CHO, it is known as aldehyde. O, it is known as ether. COOH, it is known as carboxylic acid. So these 4 are the important functional groups. So what are the important functional groups possible? OH, it is known as alcohol. CHO, it is known as aldehyde. O, it is known as ether. COOH, it is known as carboxylic acid. Now we are proceeding to the isomerism. We are taking an example. CH3, CH2OH. Another is CH3OCH3. CH3CH2OH, it is known as ethyl alcohol, and CH3OCH3, it is known as dimethyl ether. Just look at the both examples. How many carbons are there? Just look at this. 2 carbons. C2. How many hydrogens are there? H, 5 plus 1, 6. And how many oxygens are there? 1 oxygen. So C2H6O. Both of the formula C2H6O. But they are the same molecular formula. But just look at the picture. Their arrangement of atoms are different. One has OH as functional group, another has O as functional group. So, both the molecules have the same molecular formula C2H6O, but the arrangement of atoms are different. One has OH as functional group, another has O as functional group. OH means alcohol, O means ether. So they have different arrangement of atoms. Now isomerism can be divided in two types: structural isomerism and stereoisomerism. Structural isomerism can be divided into mainly three types. We will discuss with three types: chain isomerism, positional isomerism, and functional group isomerism. Stereoisomerism can be divided into two types: configurational isomerism and conformational isomerism. Configurational isomerism can be divided into two types: geometrical and optical. So again I am telling, isomerism can be divided into two types: structural and stereoisomerism. We will concentrate structural isomerism, structural isomerism, structural isomerism can be divided into three types: chain, positional, and functional group. And stereoisomerism can be divided into two types: configurational and conformational. Configurational isomerism can be divided into two types: geometrical and optical. Now we are proceeding to the next slide. Structural isomerism. CH3, CH2, CH3 and CH2, CH, CH3, CH3. So what is their molecular formula? Just look at this. How many carbons are there? 4 carbons. So C4. How many hydrogen are there? 5, 7. C4H10. So their molecular formula are same, but the structure are different. How many carbons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C4H10. So their molecular formula are same, but structure are different. Now we will proceeding to the chain isomerism. Again I am taking the example. Just look at this. How many carbons are there? 4 carbons. So C4. How many hydrogens are there? H10. So their molecular formula is same. But look at this. For N-butane, it is a straight chain. And for isobutane, it is a branch chain. So their molecular formula are same, but the nature of the chain is different. Similarly, first one has larger chain length than second one. So obviously, chain isomerism means they have the same molecular formula, but difference in what? Nature of the chain and chain length. Now, another example is there. Pentane and neopentane and isopentane. Just look at this. How many carbons are there? So first one is a straight chain, second one is a branch chain. So obviously their chain length and and the nature of the chain is different. Now we are proceeding to the position isomers. Position isomer. So CH3, CH2, CH, OH. Just look at this molecule. CH3, CH2, CHOH, CH2, CH3. And look at this molecule. CH3, CH2, CH2, CHOH, CH3. What is that molecular formula? Just look at this. How many carbons? C5. How many carbons are there? 1, 2, 3, 4, 5. C5. How many hydrogen? How many hydrogen? H3. 3 to 5. 8, 10, 13 and 1, 14. C5, H14O. 3, 6, 3 to 5, 6, 9, 12 and 13. Sorry. 3 to 5 to 7, 8, 11, 12. 3 to 5, 1, 6, 2, 8, 3, 11 and 12. So they have the formula C5H12O. So their molecular formula are same, but the position of the functional group are different. Just look at this. Here the position is at 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 5. So in the first one, the position of the functional group is at position number 3, carbon number 3, and in the second one, the position of functional group is at carbon number 2. So their molecular formula are same, but their position are different. So we called it positional isomers. Next we are proceeding to the functional group isomers. We are taking already an example CH3, CH2OH and CH3O, CH3. So their molecular formula is C2H6O. So in the first one, what is the functional group? OH. In the second one, what is the functional group? O. So their functional group are different. So their molecular formula are same, but the functional group are different. So these three structural isomer types are in your syllabus. Now we will proceed to the stereoisomers. Just look at this. In the first one, two CH3 groups are on the same side. So we called it cis. In the second one, two CH3 groups are on the opposite side. So we called it trans. So their molecular formula are same, but the position of atoms in three-dimensional are different. This is y-axis, x-axis and z-axis. So their molecular formula are same, but the arrangement of atoms in three-dimensional space are different. So we called it stereoisomers. Molecular formula are same, but the arrangement of atoms in three-dimensional space are different. So we called it stereoisomers. Just look at the second example. Here both the CH3 are above the plane. In the second one CH3 is above the plane, another CH3 is below the plane. So their arrangement of atoms in three-dimensional space are different. Means they are different arrangement of atoms in X, Y and Z axis. So we called it stereoisomers. Now stereoisomers can be divided in two types, optical isomers and geometrical isomers. So first we will proceed. Stereoisomers can be divided in two types, configurational and conformational. So we will first proceed on configurational isomers. What is the meaning of configuration? Configuration means the arrangement of atoms in three-dimensional space. So, just look at this example. This is cis-2-butene and this is trans-2-butene. So, in order to convert cis-2-butene to trans-2-butene, what we have to do? We have to break this CH3 and attach this CH3 to the which side? To the opposite side. So, the stereoisomers which differs in configuration. So, what is the meaning of configuration? One form can be converted into another form. By what? By breaking of bond and attaching the bond to the opposite side. We called it configurational isomers. So, just look at this example. This is cis-2-butene and this is trans-2-butene. How can cis-2-butene be converted into trans-2-butene? We have to break this CH3 and attach this CH3 to which side? And attach this CH3 to the opposite side. So, stereoisomers which differs in configuration, we called it configurational isomerism. That is, one form can be converted to another form by breaking of bonds and attaching the bond to the opposite side. Now, configurational isomers, similarly, just look at this A and B. How can A be converted into B? A can be converted into B by breaking this Cl and attaching the Cl to the opposite side. By breaking this Cl and attaching this Cl to the opposite side. Now we are proceeding to the optical isomers. So just look at this. This is the molecule. Light is passed to the molecule. Then the molecule rotates the light towards what? Left or right. Then the molecule is known as optically active. So when he called it optically active? So very simple. Light is passed to the molecule. Then the molecule rotates the light towards what? Left or right. We called the molecule optically active. So those who are not able to rotate the light, we called it optically inactive. So when light is passed to the molecule, then the molecule rotates the light towards where? Left or right. Then the molecule is what? Then the molecule is optically active. So if it is not able to rotate, then it is optically inactive. Now we will just look at this picture. Now, there are similarly, when light is passed, আমাকে তো বললে কেন 10 minutes. So when light is passed to the molecule, when plane polarized light is passed to the molecule, then the molecule rotates the light towards right. It is right, so it is known as dextrorotatory or D. Similarly, when light is passed to the molecule, then the molecule rotates the light towards where? Left. It is known as levorotatory or small l. So dextrorotatory is denoted by plus and levorotatory is denoted by minus. Now there are various types of light. Monochromatic light, plane polarized light. We will study about monochromatic light and plane polarized light. What is monochromatic light? Very simple. Just look at this. So, very simple. Light is coming and it reflects in infinite number of planes. Light having a single wavelength and reflection occurs in infinite number of planes. What is monochromatic light? Just look at this. The light which is coming, it has a single wavelength, but reflection occurs in what? But reflection occurs in infinite number of planes. We called it monochromatic light. So now we are proceeding to the plane polarized light. So what is plane polarized light? Very simple. The light, it is a single wavelength, but reflection occurs where? Reflection occurs in a plane perpendicular to the direction of light. So we called it plane polarized light. So what is plane polarized light? This light has a single wavelength, but reflection occurs where? The reflection occurs So what is plane polarized light? Just look at the plane polarized light. So this light has a single wavelength, but reflection occurs where? Reflection occurs perpendicular to the direction of light in only one wavelength. So we called it plane polarized light. So in this lecture we have completed up to the plane polarized light. In the next lecture we'll start with angle of rotation. So thank you for your kind attention.